I'm Bruno. I'm from Cartesi. I'm the head of ecosystem growth at Cartesi. I joined Cartesi in the early days, back 2020, and still super active in ecosystem and passing through an amazing phase in the project.
Same question to you, please, sir.
Yeah. My name is Chandler. I've worked in the crypto industry for a couple of years now, from 2017 in various roles, centralized exchanges, a couple of DeFi platforms, and I've recently joined the Avail team to help with their similar role, ecosystem growth, partnerships, scaling out the data availability solutions to more use cases.
Before we dive into the event and sort of why we're here and what we're all working on in the industry, I want to ask you how you originally got into the industry. What was the sort of spark?
Yeah, I like this question. The way I describe it is the penny drop, and like a coin being a coin moniker, it worked quite well. I started in a economics undergraduate, then migrated a bit more mathematical and computer sciencey, which meant I had a lot of opinions on the intersection between computer science and economics. And somebody told me about Bitcoin, and I immediately critiqued it. Very surface level, news orientated. It was known as the scam coin and the drug cartel coin at the time. That was very surface level, and somebody kind of like challenged me to look at it a bit deeper. And once I had it, like kind of that spark just hit that this kind of would work. At the same time, I was graduating and going to go work as a finance, mathematical, computer sciencey type graduate at a bank. I lasted a very short time at this bank, and then joined a crypto startup, and that was the origination of my story, and the rest is history.
Here we are.
Nice. Well, my days in blockchain precedes Cartesi itself. My background is engineer. I'm a telecommunication engineer by graduation and master's. And I was working around 10 years in Qualcomm as a strategic consultant and giving consultancy for C-levels in operators around the world. And back 2015, 16, I started diving into blockchain technology and studying and getting passionate about that. Initially, of course, getting exposed as a regular individual investor, trying out all the ICO mania back 2017. And 2018, I had an opportunity and a life decision and on pivot career path. I left Qualcomm and joined full-time a blockchain company called Bitfury, based in the Netherlands, in Amsterdam. And since then, I'm full-time in blockchain. 2 years in Bitfury as the head and director of pre-sales for Bitcoin mining and blockchain. They used to have a private blockchain. And 2020, I received an invitation from the founders of Cartesi to join as head of the BD department. And since then, has his history as well.
So we're here at the modular security event in Brussels, not too far from Amsterdam, where your sort of crypto journey, your blockchain journey began.
Exactly.
Bruno, what have been the key talking points today, and what are the key takeaways, and what are we actually doing here?
It's a very good question. I think we need to give a step back and why we are here today doing those things, right? It's clear that the blockchain infrastructure, as it is nowadays, presenting serious limitations, right? Technology limitations, barriers that are avoiding, I would say, new use cases to be explored and consequently avoiding easier mass adoption by the technology, right? And the path on exploring how to unlock those limitations generates a lot of conversations on what are the technical paths that should be trailed to handle those limitations. And what we saw today here in the modular event is discussions about two big problems. One is how to make interoperability with this more fragmented ecosystem that has advantages, but also impose these difficulties on interoperability. And the other one was how to make the systems safer, right? Which is the fundamental ethos of the blockchain that is unnegotiable, right? Blockchain, I would say, decentralize the trust, so security is a must. And so it's why we are doing today. Here's debate on those paths, and lovely debates and an amazing environment.
And I'm going to ask you a slightly different question. We're here also during the week of ETHCC. which is obviously one of the the largest blockchain-related conferences in the world. Have you been attending the conference, either the main conference or the side events? And if so, what have your key takeaways been from this jam-packed week of events?
Yeah, the conference has been a highlight on just the latest levels of outputs that have happened over the last year. One of the interesting facts about this ETHCC and specifically is the sheer number of side events. Now, what that means is something that our ecosystem will kind of have to figure out. But the number of teams building, the number of teams that want to kind of create some sort of attention on their specific solutions has completely ballooned in this space. That's generally a good sign. Some of the key takeaways, I think generally from my experience from ETHCC last year, is that the interoperability problem is still fundamentally front and center. Some of the same problems that we were highlighting in the last one have proposals on solutions at this ETHCC. So I don't necessarily think this is like many areas of like cyclical conferences where we've had set of problems, and within a year we've seen solutions. Now it's actually been kind of a bigger problem that's arisen, and kind of my thesis point as to why I think that's been the case has been at the same time this Cambrian explosion on modularity. So what does modularity mean? It's ultimately a breaking up of what a blockchain can do and how it can function in various component parts. And when you do that, you exponentially scale how it means to communicate within an ecosystem. And a very easy example to understand is, to send an email is quite easy to another email client. We can understand exactly how that works, and to this day, most of the world's economy runs on email, and the same thing you can say for messages. But imagine if you had to send a text message that eventually arrives to the destination as snail mail. What are all those complex little mechanics that need to happen to make that actually arrive is not that trivial to solve, and now we have to do that in a trustless environment. Just completely blows that out of the water. So that's kind of the magnitude of the problem that I think interoperability sets to this day and age. And so it's not actually surprising to me in any way, shape, or form that we've had to repeat many of those topics. There are many other sub-themes that have come out of ETHCC, but that's kind of my takeaway as to why specifically interoperability has been this recurring theme.
And jumping into that is very interesting, because what I've been observing is these limitations that we mentioned about blockchain technology, and especially related with monolithic infrastructures, that it's very difficult for one specific set of configuration be capable to address different technical requirements from different use cases, right? Yeah. A gaming application, an IoT application, an AI applications, those applications, they have absolutely different requirements on data capability, on power, computation processing, on program language that should be required for that, on latency. So the modular approach exactly tries to address this angle, to address what applications they need, and that is super important for unlocking new use case, right? And that is where protocol like ours, right, combine very well, right? Addressing different specific sets of the unlocking the restrictions of blockchain, cooperating together, understanding the angles of the security guarantees that you have to keep it safe, and with that capable to address bigger use cases, right, and more complex ones.
Yeah, couldn't agree more on that one. I think when we think about these use cases as well, it's always nice to ground it in some sort of reality. And the way that I kind of like to think about it is, the more you decide to choose for yourself, the more level sets of freedoms that you have in any developer ecosystem, the more Cambrian explosion of new ideas that can become possible. And the best example I have is the minute we had 20 early 2000s internet, YouTube was the cutting edge. Now we take it for granted, and we can stream 4K today in amazing fidelity. And as the internet grew, the demands of what you could do with that capacity was the fundamental story of the internet. And I feel like these discussions on scalability, what you can do, new use cases, is fundamentally going to be the story of that new internet that will, we always opine towards. And to me, that's kind of the story of, the very little steps that happen in one conference to another. These little discussions that happen on these panels, but they do have a meaningful trajectory within that entire ecosystem. And we've mentioned, our two projects and what we want to do with them is ultimately to be some part of that story.
Yeah, absolutely. And from Cartesi perspective, we have this thesis that blockchains inherently have limitations on computation, how much computation it can handle. So that's one of the problems that our project tries to handle, right? It's we scale a lot the computation that we have in blockchains, and that will address more complex coding. And once we do that, we are able to deliver a virtual machine that is much more robust and expressiveness than the virtual machines that you have on the base layers of the blockchain. But we do that keeping the same secure guarantees as you would be programming directly in the blockchain. That's called Rollups, okay? What is the important thing on that is once you scale computation, naturally the applications, they start being more data hungry. Is where the scalability of data availability becomes such important. And doing that both is unlocking what we call the cone of innovation, which is super important to open new use case for blockchain, which is ultimately we will drive more applications to address the real life people's problems, right? This is the only thing that will address mainstream adoption. When you start fixing daily life problems and scale those things, it's a super important thing to unlock the limitations that you have in blockchain to address those problems.
I want to go a layer deeper in that because before we get into discussions about adoption and really how we're going to bring sort of the next billion users, I think it's important that we also discuss. You mentioned the developer ecosystem and some of these innovation milestones. Concretely, what have the innovation milestones, do you think, been over the last, let's say, 12 to 24 months? Given that we're still sort of focused on some of the same issues, some of the same narratives are coming back at different conferences year on year. There's got to have been some significant milestones that have actually allowed us to get to this point. So I'm curious what you think.
Yeah, I think slightly before the last 2-year timeline, the biggest issue with many blockchains quite concretely was the scaling problem. Bitcoin took the Lightning route. Ethereum had originally the Plasma route. For anyone that's actually listening to this, there was a proposal before the Plasma route that has a very specific name, if you can remember it. You're an OG. But these kind of ideas compounded from that original idea to Plasma, and now what we have today are what we call rollups. The construction of a rollup fundamentally is not actually even just one specific definition. There are multiple takes. I think the two common themes that we have today are optimistic and ZK. So the debates among what is optimistic rollups, the canonical ways of debating within that space is the fraud-proof mechanism. In the ZK space is the prove verifier times. And how composable these two ecosystems can be. So that's been largely a lot of the debate and the innovation. If we just look at the ZK component in itself, how long it took from a proof 5 years ago to a proof today is orders of magnitude. And it's kind of the same thing as saying 3G to 5G. These are step changes, genuinely step changes. And so that's been an interesting side of the innovation space that we're quite keen on. And then the other one, which is more related to how we're going to be working together, is this idea that you don't necessarily have to buy an entire package of a blockchain and put it all together. You can compartmentalize that. And what does that compartmentalization mean as you think about different use cases in the future, which ties back to the original theory that we've been kind of alluding to, is fundamentally a blockchain is a set of transactions that are ordered and some sort of execution that happens. And those ideas sound quite simple, and when you package them together, they make a lot of sense, but when you break them apart, the sense makes less sense to kind of what can kind of like happen as a result of that, and what we can now do as a result of changing where the data sits and how you can sample that, to how it can be executed, to what that means for my application, for my use case, for what I want to do in this world, are very interesting, new and important points that I'm personally very excited to chat with you about.
I'm under the impression that a lot of technical challenges are being addressed
Yes.
behind the scenes.
Yes.
There's a lot of collaboration that's going on, among teams that the rest of the world doesn't necessarily hear about. Even when you attend conferences like ETHCC, some of these sort of more technical discussions happen at side events like this one, and we heard quite a heated discussion earlier. Bruno, I think you were there for a majority of it. There was a lot of debate, and not disagreement, but let's say debate about proofing and what the sort of future of proofing is going to look like. And people have debated if TVL is going to shift in the L2 space, but I want to talk about the technical challenges that we're facing. If we can't even agree on sort of the future of proofing, I think it's maybe rich of us to expect people out there to understand the technical challenges that technical people are facing. So can you sort of run through some of those technical challenges? Maybe it's about interoperability, maybe it's about composability that you're working on day to day that's part of your collaboration going forward.
Yeah, it's a very good question. But giving a step back on that, it's important for us in the industry reach a level where we can abstract away the complexities of the infrastructure or the protocol stack that a regular developer needs to have to develop his own application, right? I don't see a way for us to have a mainstream adoption with millions of developers using blockchain technology if for each program they want to develop, they need to get an intricate details on which protocol they're using, how they're going to combine that. It's simply not feasible, right? A regular developer in Web2, he doesn't do that, or she doesn't do that when she's programming in Python, for example, in Web2, right? Doesn't go to AWS to understand how the VPSs are composed and what they should they do some tweaks there. So it's up to us to deliver to the developers a protocol that fits the requirements to address the use case they're building, right? This is important. But of course, nevertheless, behind the scenes, we need to ensure that whatever delivering to these developers, it's safe, can make an interoperability, right? And can work smoothly, right? And what we're seeing here are protocols that are working on that lower level, being capable to discuss on and agree on the fundamental problems to work on. And moreover, those are different nuances, different interpretations that also come with different versions of these protocols that will be combined depending on the use case you need to address. So you're talking about ZK proof, optimistic, both are valid solutions, right? With slightly different approaches. And it's a matter of engineering. Every engineering solution comes with design choices and compromises, right? This is the basic of engineering. So ZK have their design choices, their advantages, their disadvantages, as well as optimistic rollups or optimistic solutions, the same, right? Data proving, different methodologies of data proving as well gives slight advantages. Right? It will be up to the protocols to when harmonize and combine to deliver to the developer, the regular developer, an infrastructure to just abstract, deliver what they need. You need low latency, you need a lot of data, you need permanent data or no permanent data. You need a rich environment to program, you need a lot of computation or you don't need it, right? Yeah. And so on. So, and what we're discussing here is what are the key things that are locking up the evolution of this infrastructure, right? Computational power, data availability, and of course with the fragmentation of protocols, how they can integrate together to give a smoother experience in terms of money movement, which is liquidity, in our point of view. The most important thing to be interoperable on protocols in a smooth way will be access to liquidity, right? Which is super important. With the fragmentations, the liquidity gets fragmented as well. So have a composable liquidity is super important, and there are projects and initiatives working on this problem as we speak. So I feel that the entire industry is finally establishing the baseline, the roots of the infrastructure that will be really ready to get new use cases, more mature use cases, and finally bringing new verticals into blockchain, and with that, getting more traction and adoption, right?
And on that note, I think it's a fair time to bring up next-gen VMs. Curious from a technical perspective, what you think the connection between next-gen VMs and finding those use cases and maybe allowing developers to actually explore those use cases is going to be. But before we get that, can I just get you to sort of define what they are and maybe what makes them next-gen?
I think I can jump on that. So there is a lot of ways to classify those VMs. Because the first VM that was capable to run a full verifiable logic was the EVM from Ethereum, right? The EVM is a wonderful piece of technology in terms of what they achieved. The Ethereum network achieved the decentralization of a truth, and this is a remarkable result. And they did that with design choices, right? They have some primitives, and they stick with those primitives that end up with some characteristics of the network that the VM couldn't handle a sophisticated virtual machine. So Solidity is a very simplistic language in certain aspects that is difficult to program, and is not so much expressive, right? It's not a full operating system that can allow you to do a lot of things as the mainstream developers they do. So novel VMs are coming, and most of those projects, they are stepping up the shoulders of the giant, as I like to say, as Cartesi, for example. We're not here to replace anyone. We are here to augment what is possible to be done in Ethereum ecospace. We're delivering an augmented capacity for developers to do more in Web3 is what we're doing. So these VMs, they're coming exactly to try to give a more programming capability and rich programming experience to developers, right? And Cartesi is exactly that. We are a modular execution layer. The core of our technology is this novel VM, which is based on RISC-V architecture that puts an entire Linux OS. And why that matters? It matters because you gain an entire expressiveness operating system with the same security guarantees of the Ethereum, meaning that for the security point of view is more or less the same as programming directly in Ethereum. Okay? But you have that in this rich VM that can allow you to get different programming language, it can get libraries, do programming almost as a regular developer in the mainstream industry, right? And suddenly, we solve a lot of problems on more tooling to develop rich, solutions, but also we are making easier to onboard these millions of developers that we have in Web 2 that are not currently in Web 3. To give an idea, we have 400,000 developers of Solidity worldwide, with between 30 and 40 active monthly users on the whole ecospace, getting all blockchains, right? And we have 25 to 28 millions of developers worldwide. So we have a drop of ocean on onboarding professionals in this industry, and mainly having a very expressiveness virtual machine that can handle Python, for example. Only Python is 12 million users, right? So if you can start onboarding them, and they can get rich programming in a much more common and known environment, using the tooling they have, we start getting these complex applications that also, in that sense, will demand more data capabilities, will demand lower latencies, and you see that this modular approach solving those problems, and then coming to a situation where developers can finally deliver new use case to the ecosystem.
Yeah, I think the analogy I like to draw on that exact value proposition that you're outlining there is when we develop programming languages, we made applications for the internet, our computers, and then we made phones. And phones were a completely brand new programming language paradigm that you could take courses on, you could learn, and ultimately it was an upskilling situation. And if you looked at the fintech tech scene back in the SaaS model era, in the height of that era, you would have the web team within an organization, and then you would have the mobile team. There'd be two distinct teams, two distinct cost centers for fundamentally building the same application across platforms. And we see that in the blockchain space right now. one programming language is not the same as the other, and there are so many nuances that fundamentally a Solidity engineer and a different type of blockchain engineer are not the same skill set, and it's not. Many elements are transferable, but the skill sets in terms of security and best practices, it requires a lot of work. Mm-hmm. But we have this huge amount of developer experience in kind of these natural languages that you mentioned. Like Python's a great example. I'm personally a big fan of Python, and so to build that into a way that you can then just build an application within the ecosystem is really great. And I think a good example here is like when the reason why iPhone apps became really easy to develop for is that they natively just like abstracted a tiny away from what developers were already working with, and so that learning curve was tiny, and that app model exploded. So simply by just doing the same thing, but in this new programming paradigm, I think is an immensely valuable proposition.
Yeah, absolutely. And going further in the phones, right, industry, this new paradigm of programming, the mobile phone, right? They brought this easier way to onboard developers, and moreover, this phone brought a lot of functionality that was very difficult before the phone, the smartphones. You have it. You have access to location. You have access to media. You have access to other applications in the same background environment. And that start making these people finally building applications that make sense for users, right?
Yeah.
And in an abstract way, they gave all these APIs, all these functionalities for free for developers. The developer didn't need to go and figure out how to acquire GPS coordinates from the phone to his program. The operating system of the phone gives that easy to developers. It's this abstraction of complexity that we are talking about that needs to happen there. Because if it was not there, you would not have millions of developers building phone applications. When you have a phone call, right, you're not worried if it's a voice call, if it's a data call, if you're checking an email or doing a voice call, you have no idea what the phone is doing with the network, right? Yeah. You just use it. Yep. These things were abstract away from the user. That's why you have more than billions of phones. There are more devices in the world than people, because people in general have more than one device, right? Yeah. That's why you reach mainstream adoption.
I can feel your optimism here and this desire to sort of promote innovation, and I have a rather specific and concrete question on that, because talking to people here, there seems to be this general consensus that innovations like next-gen VMs are really something that has the potential to drive growth and innovation in this space. I'm curious if you both agree with this in a fundamental sense, or if perhaps you are, in your professional life, more focused on the potential limitations around, the complexity of integrating some of these VMs into existing systems. How do you sort of choose to think about that opportunity versus there are challenges and we need to work on the challenges?
Yeah, I'm going to be very general, and I'll open it up to you to be very specific here. But in any new paradigm, there's trade-offs, and I think the concept that we're trying to put forward on this panel right now and in our discussion is, fundamentally choosing a new, different paradigm means that you're optimizing for certain functionality. And so for a next-gen VM, what you're really trying to do is make sure that the value proposition for the developers is as easy as possible for the same level of functionality that you get within the blockchain ecosystem, and make that job really, really easy for them. That trade-off space is a fascinating intellectual debate, but the value that you gain from just allowing a user or a naturally proficient developer just to wake up one day, start writing their implementation, and have something be deployed, I think is going to be extremely important for that adoption curve. So in my mind, these trade-offs, I think, typically have always been in the blockchain space, kind of like security versus technically the technical speed at which you can execute something in versus how decentralized it is. That's always been, in some way, shape, or form, the trilemma that we've always been playing around with, and we've kind of left users as the last thing. I think the idea of thinking more closer to the user, the end user, and ultimately the types of applications that you can build is far more valuable as we kind of somewhat settle some of these interop and technical scaling debates. They'll still be prevalent, but in terms of where I like to see this moving forward is ultimately, all right, great, we've solved some of these problems, let's build some applications that people will use.
Exactly. Fundamentally, what drives adoption is useful applications for end users, right? And just a step back, there are two levels of frictions on the blockchain technology nowadays that is limiting mass adoption, right? One is the infrastructure side. We are unlocking that with projects like Cartesi Avail, but also on top of that, you have friction on the end user side, on all these wallet things and etc. There's been massive work on that direction as well to make it smoother, abstract away complexities for the end user. So it's a lot of initiatives that compose and bring the technology more mature for a moment that is becoming capable to address this real life problem, right? But talking about the VMs and the challenges, VMs like Cartesi, for example, it's going further than only allowing developers of Python to come and program in decentralized applications, right? Is the ability to use 40 plus years of mature programming environment knowledge base on this new industry. And that includes libraries, this concept of make a program and plug in libraries that can help you to make much more sophisticated programs right now. Before Cartesi, it used to be absolutely impossible to be done in blockchain. Now it's possible. And that unlocks a huge amount of use case. I like to bring tangibility to those conversations because it makes it easier for the general people to understand. Imagine that you're now working in the carbon credit industry. And I'll give you a very clear use case that combines Cartesi and Avail. Okay? You get now a satellite image, high definition of rainforests where carbon credit is being issued. Right? You get AI module that is trained, and an image recognition library that is trained to recognize native vegetation. Right? Imagine that through data availability, we can get this big file and put in the Cartesi machine where you have a Python program with an image recognition library, TensorFlow or something like that, that can automatically get this file and say, okay, you have 75% of native vegetation in this area. You have the right of this carbon credit here. And this is end-to-end fully verifiable without any middleman going there and trying to measure or getting middlemen that could corrupt the process totally in a much shorter time, cheaper, and fully verifiable, right? You get an image of the satellite and you get this file with digital signature that a full OS virtual machine can work with, can unpack this file because maybe it's a zip file. You can unpack that because now you have Linux, right? So you understand that the level of refinements on the programming that you can have, that is impossible to have nowadays. Yeah. Right? And you unpack that, you put in a Python with an image recognition library to read this, and this is only the beginning. You have tons of those real applications that could feed a financial DeFi, intelligent DeFi module that could generate lending for you based on this carbon credit issue certificate that you have as a collateral. Everything seamless, fully trusted, and with a fraction of a cost of a nowadays systems and a fraction of a time. Yeah. So you're optimizing OpEx, you're optimizing time, you're getting new ways to combine those products, generating new ways of monetization. Right? And that is what I'm super excited to see, those things unlocking it. And a clear use case of Cartesi and Avail, for example. Right?
A great way to think about it is, at the end of the day, whether you're running a blockchain or you're running an entire virtual machine or you're running the software that runs on SpaceX or Teslas, they're all ones and zeros at one level. And then we built CPUs that kind of abstracted a little bit of what those ones and zeros meant. We built some expressiveness into that. Then we built programming languages, and then we built like these huge levels of stacks around them. And blockchains are actually kind of like very low on the stack. And now to kind of like bring a lot of that like top level area is like great. And like now with the advent of AI coming around, hugely computational, how do you bring that on chain? There are some cases that I think are interesting, but fundamentally they're relying on some sort of like compute here, bringing them on chain. But what happens if we can do that natively on some sort of like programming stack that developers are familiar with? I think that there's a slightly different proposition there. But kind of to tie into like the Avail side and kind of why we're kind of excited about this is that you spoke about the word verifiability, and verifiability is actually the crux of the most important thing as to why this is important. And verifiability really just means ultimately that you can reproduce what somebody else did. The inputs that you put into a recipe are very clear when the chef's done them, and you can check that the output that the chef made is exactly the same as you did, because you just followed that recipe. Really important points around that fact are that you can find the recipe. This is the data availability part. Like, there's the book that holds that recipe, or you can find it on the internet, or wherever you find it, you can very clearly always go back and reference it. And that the order of steps that you do are also very important. To say something like a good example is, 1 plus 3 is the same as 3 plus 1. But when you get into some more complex calculations, and we've all done this in kind of elementary level schooling, the order of operations when you get to more complex type mathematics where you've had multiplication and dividing, the order of operations is really important. And the same thing that happens in blockchain. And so data availability is that solution for ultimately bringing the order of operations, the steps that you follow in your recipe, and being able to find that recipe quickly and easily, and so that if you have to verify something quickly, or it's really sensitive information or really important to your application, that you can do that in a meaningful way, specifically because like speed and time of execution is important for the general computing world.
I'm going to hop in there because we've talked about quite a few different things here, some of the technical challenges that we face as an industry, how we sort of seem to be overcoming them, some of the discussion that we're still in the process of sort of ironing out. And we've touched on some very concrete use cases as well that I really think can begin to drive adoption once we create the right type of tooling and the right type of environment for the developers to create what it is that they want to create. I want to ask you on that note for some very concrete examples of projects and initiatives that you're both working on in the next 12 to 24 months that we can look forward to and follow along with. And I'll start with you, please.
Yeah. So we started this conversation with Interop. One programming paradigm being able to talk to another programming paradigm, and that connective tissue is valuable, and that connective tissue is also a part of what's going to ultimately compose what we look forward to within the internet. I can load many websites together and do many things on the internet, watch a video. The types of data that I input and kind of send out into the internet kind of all is connected, and we expect that from blockchain. And so what we're very much looking forward to is building out the next version of what Avail is working on, and that's the Nexus product. It's on our website. You can have a look at the specifications, but ultimately it's this connective tissue that allows blockchains to be able to talk to each other very succinctly in a way that allows a level of interoperability based on our DA solution, which is kind of the next step. Now that's very general approach. You wanted a concrete example. If you right now want to be able to do anything on another chain and your funds are on one chain, the step is bridge. Press refresh, waiting for this bridging action to happen. It arrives at the other chain and you're like, great, okay, then it's arrived, now I've got a deposit, and now that you wait for that deposit, and then you've done 3 transactions and you've waited a bunch of time. No one has the attention for that, and no one's interested in that. Like we all have better things to do in our world. In a truly interoperable world, you would be able to just simply say, all right, I want to do something. The application is there, and all it is from like the way you would think about it is an API request, but there is this connection that happens, and so 3 transactions are bundled into one, and it's all interoperable, and so the funds are routed seamlessly abstracted away in a way that kind of like ultimately gets to the destination chain, and you have the outcome that you want very, very succinctly, and ultimately then you can go about your day without having to press refresh on that bridging action, and then think about 15 different trust assumptions and think about changing your MetaMask wallet around. Ultimately, it just is meant to happen. That for me is a nirvana state for I think 12 months time from now, and I very much think we can get to that stage.
Mm-hmm. Yeah, it's I would say that everything that we're discussing here, I believe that down the line, mainstream will be when you're using an application and you have no idea there is blockchain behind it.
Yeah.
That is a sweet spot. And then say, this is mainstream innovation. A lot of projects still try to sell the tech rather than actually the solution they try to solve, right? It's typical from very early stage technologies and maturity levels. Right? What we're seeing in Cartesi is the very initial first signs of applications that are using the fundamental properties of the blockchain verificability, for example, and exploring those properties in a business case in a way that it would bring novel applications that would be impossible to be done in a different part of the paradigm. So one of them is Rives, is in the vertical of games, but it's not a game, it's a platform that it's to allow content creators economy, developers creators economy, meaning that it's a platform that allows developers to build fully verifiable games. And that unlocks a lot of interesting economic mechanisms on the way to form your community, right? You can do tournaments, you can create some moments and share that because everything is verifiable, and so on. So we are seeing Bubble Wars, which is a game that is super fun, viral style game that is just one bubble fighting to eat eaters from the other ones, right? And this is made with the physics engines that you use on games on mainstream. Because of Linux VM, you can reuse all these let's say, libraries and reduce a lot of your development time. Okay, and going further than games, I would say IoT applications with carbon credits, with smart cities. The municipality monitoring the bus route, and if the bus goes out of the route, they can immediately apply a fine because all the data that's being generated is fully verifiable. And then this automatic logic that is not in control of anyone can execute what has been programmed. And it is super important to give transparency, clarity, in a relationship, for example, municipalities and the service providers. So smart cities will be an amazing fertile terrain for blockchain technology behind the scenes, right? As well as IoT in general, a little bit of AI as well. Of course, massively use of AI with blockchain technology right now is not that real because of the computation required for that.
Yeah. But I think that's a killer use case fundamentally, right? It completely breaks the paradigm. If you can run AI models in a Linux environment and have all the guarantees of a blockchain, that's like...
Nowadays we already have, right? And one girl in our hackathon, she implemented an Alpaca LLM, which is a small chat GPT, fully verifiable. Of course, you cannot run chat GPT 4.0 in the blockchain infrastructure.
You can't do that on a cell phone these days, right?
In one moment, but in small logics, image recognition, small logics, you already can build it. So there's tons of things coming with the infrastructure that we're planting the seeds, and Cartesi is already available, right, and can be used. And once, for example, we finalize the integration works with Avail, you get this massive bump on data availability that will allow you to do much more sophisticated and robust applications. And then the fun starts, right?
Yeah.
Then the fun begins.
Looking forward to that fun, definitely. I've got two questions for you each. One's really easy and one's really difficult.
Okay,
the really easy question is, where can we follow along with the developments that we're all looking forward to? Starting with you. At
Cartesi, we have a lot of our actions completely transparent public. We are a decentralized project, and you can follow on our Discord or in our Cartesi project Twitter, where we put monthly developers recap. We have open call community calls, developers recap. We are constantly publishing those informations in our official channels. So I would say the Discord and the Twitter are the best channels to follow our news.
Stay up
We have
to date.
plenty of that. Soon, hopefully, we'll have I work with a smart city in a municipality region here in Buenos Aires. We're showing these IoT applications in smart cities. It'll be super cool projects. And yeah, I'm excited to see those coming. But those channels are the best ones to follow us.
We're going to stay up to date on those. What about Avail? Where can we follow along?
Yeah, Avail's project vision and space that we want to solve for is already on our website. You can go read the vision. It's very well documented and very simple to understand. In terms of the day-to-day developments, we post very actively on Twitter. We're very active in the scene, so you'll see us at multiple conferences, debating kind of the dynamics of what's happening. Actually, I would highly recommend you stay connected because we have some announcements coming in the near short term.
Nice.
Certainly will be. Now the difficult question. I'm going to ask you to give me a bullet point list of the points that we've covered today.
How many bullets?
As many as you want. At a very high level, what are
Yeah.
sort of topics that we've discussed that do you think are pivotal for the industry, pivotal for the work that you're doing, and pivotal for the collaboration that you guys are carrying out?
Changing the game between being very specific to what matters to your development ecosystem, to generalizing it into what already exists in that world is a huge value unlock. The scaling debate has gotten to the point where we now can do that, and so can the interop between the various scaling solutions that are out there. So those are 3 bullet points that I think summarizes the conversation. And then the last bullet point I think will very much be what you can build with that is actually so close to what the current fairly close to what the limitations of what compute looks like today. So when we had small bandwidth, we had a lot small applications. Now that we have large bandwidth, we have 4K video, and to me that next step is going to be pretty epic.
And I want to ask you to summarize the main talking points from the entire day, please.
We believe that collaboration is more present in this industry than competition. It's through collaboration with meaningful projects like Avail that we can fast track an infrastructure that can address the real demand for and solve problems and get us to mainstream, right? The second is modularity is a very interesting way, and the way that Cartesi believes that we can compose those different protocols to deliver an infrastructure that can address different use case requirements, right? And the third is the challenges that modularity brings, because they have benefits, but they have challenges. They are being addressed as we speak. So I'm fully confident that those technical challenges will be handled, and they are right now being handled for different projects that could even enhance how these modular protocols will help driving adoption. And last, it's a great time to be in the industry, right? It's seeing all these things unfolding and getting shape and unlocking new use cases, and we're seeing that the blockchain technology is becoming more relevant.
Gentlemen, it's been a pleasure talking to both of you. Thank you so much for making time to chat with us.
Pleasure of mine.